Alright, so just to extend the question for checkpoint 17 of the electromagnetism, right? So we are asked to find what is the magnetic force on the short straight wire due to the circular coil. So for this question, we know that the answer is A, which is upward. Why is that so? Because always remember, the short straight wire will want to interact with the B field of the circular coil. So what happened is that if you use your right hand grip rule, the four fingers you curl, right? So the magnetic field that is inside the circular coil will be into the paper. So using then next, they say they want to find what is the magnetic force. You use your Fleming left hand rule, FBI, right? So your index finger point to the paper, your middle finger point towards the right hand side, right? You will see that the force that's acting on the short straight wire is upward. So that is the answer. That's the solution for this question. Okay, what if I add one more question to this question? Is that okay? What about the force or the magnetic force that's acting on the circular coil due to the short straight wire? Okay, so how do we do this question? Very simple. First thing first, this circular coil is also going to experience a force due to the short straight wire, because the short straight wire also produces its own magnetic field. If I draw the magnetic field due to the short straight wire, right, you will see that, okay, so for this, right, same idea, you use your right hand grip rule. So your thumb point towards the right hand side. So what happened is that, the top part of the short straight wire, you will see that, you will get something like magnetic field is out of the paper. So it's out of the paper like that. So remember, out of the paper is dot. Okay, then next is into the paper. The bottom part of the short straight wire is into the paper. Okay, so based on this idea, right, you will see that this part, for example, okay, so this part of the wire will experience a magnetic field out of the paper. So you use your Fleming left hand rule. Your Fleming left hand rule, FBI, right? So B is out of the paper. Your middle finger is towards the right hand side. Then next, your thumb will be pointing downward. So this thing is downward. So the top part of the circular coil, you'll see you will experience a force downward. Okay, what about this part of the coil, the bottom part of the coil? So the bottom part of the coil, you will also experience some force. Okay, so based on the picture on the right hand side, so the magnetic field is into the paper like that. So you just draw, right? You'll see that this part of the wire, right, the so-called the bottom part of the circular coil, will experience a magnetic field into the paper. So what happened is that you use your Fleming left hand rule, FBI. So your so-called index finger into the paper, your middle finger towards the left hand side. So your thumb is pointing downward again. Yeah, so this is the so-called the force acting on the top part of the circular coil and the bottom part of the circular coil. Alright, so yeah, so that is add on to this question.